I've rewritten our balanced chemical equation. 3 copper 2 chloride plus 2 aluminum metal react to produce 2 aluminum chloride and 3 copper metal. We can interpret this balanced chemical equation a couple ways. One is to say that it's 3 molecules of copper chloride reacting with 2 atoms of aluminum, and those combine to make 2 molecules of aluminum chloride and 3 atoms of copper solid. That is an appropriate interpretation of this chemical equation. We could also say that it's 3 moles of copper 2 chloride reacting with 2 moles of aluminum, creating 2 moles of aluminum chloride and 3 moles of copper. That would be true. What's not true and cannot be said is that 3 grams of copper chloride react with 2 grams of aluminum to make 2 grams of aluminum chloride and 3 grams of copper. We cannot say this because these different species have different molecular weights. So the top 2 interpretations are okay. And we're going to use the second one to define what we call stoichiometric ratios. That is to say, we have a bunch of equivalents. We can say that 3 moles of copper 2 chloride equal, it's sort of a stretch to say equal, but in our way of writing equivalence and getting conversion factors, we could say that 3 moles of copper 2 chloride equals 2 moles of aluminum chloride. Now you know how to take an equivalence and use it to create conversion factors. The conversion factors that come from these molar equivalents are called stoichiometric ratios. So we would say 3 moles of copper chloride per 2 mole of aluminum chloride, and the multiplicative inverse. So there's all kinds of equivalents we could have here. We could have an equivalence between 2 reactants. 3 moles of copper 2 chloride equal 2 moles of aluminum. That might be useful if we're trying to figure out how much of the 2 reactants to combine in a reaction. Why don't you see if you can figure out what all of the potential equivalents would be for this reaction and give an example of a conversion factor for each. Pause the recording now, write a few of them down, and then when you're ready, start the recording again to see the answers. Okay, now shown are, I think, pretty much all of the equivalents that are possible from this reaction, and some examples of the conversion factors or stoichiometric ratios that you can derive from them. In the next video, I'm going to show you how to use them.